let's go ahead and let's go over the 2 warm-up problems that you guys did today, okay? So your warm-up problems, you've got number 1 and number 4 on the back of last night's homework, right? Okay, so number 1, what was your y-intercept of the first equation?
-1.
-1, that's down here. Okay, what was your slope?
2 go up 2 over to right 3.
Yeah, up to right 3 for this one. Okay, so from the y-intercept up to right 3. Okay, if I need to get another point, I can also do the reverse of that. What's the reverse of up? Down. What's the reverse of right? Left. Okay, that would give me an additional point to make my graph a little bit more accurate. Okay, so there's my first line. Okay, now for the second equation, the second one's also written in slope-intercept form. So what's your y-intercept on the second one? +4, so we're going to go up 1, 2, 3, 4. Put a point there. Okay, now, what number is really in front of the x here? -1. So your slope is -1 over 1, right? So if that's the slope, what direction am I going since it's negative? Am I going up or down? I'm going down and right. Okay? So from this point, I'm going to go down 1, right 1. Down 1, right 1. Down 1, right 1. Down 1, right 1. Okay, so look at where the lines are crossing. Okay, when I walked around and checked your guys' homework, a lot of you guys did a good job where you graphed. Okay, especially like on the first night of homework, you graphed, but you didn't actually write down if they crossed what the answer is. So remember, the graph is the work, okay? What is the actual answer for number 1? It's
The point.
the point. What's the point? 3, 1. Okay, so for your first problem, your answer should be 3, 1. That's your final answer. All right? How many of you, raise your hand if you got that one correct? Okay, good. If you didn't get it correct, make some corrections and fix it. Okay, are there any questions on how we did that? Okay, all right. Let's take a look at the next one. Okay, the next one is number 4. Okay, now I know this one looks kind of weird, but do you have an x and a y? Yeah, so it's a diagonal line. Okay, what number is being added or subtracted at the end here? 0. So your y-intercept is 0. So I'm going to go to problem 4, okay, and put my point at 0. Now, my slope here is +2. What's really in the denominator of +2? 1. Okay, so your rise is 2, your run is 1. All right, so we're going to rise 2, run 1 as far as we can. If we need to, we can do the opposite, which is down to left 1 to get some additional points. Okay, so there's what your first line looks like. All right, so now let's take a look at the second equation. Okay, is the second equation written in slope-intercept form? Yes or no? No, okay. What's wrong with it? What needs to move? X. So let's subtract x from both sides. Okay, when we do that, we're going to go ahead and get y equals -x. What kind of 3 was that? +3, okay? So what's your y-intercept there? +3, so up 1, 2, 3 on the y-axis, put your point. Now, for your slope here is -1, right? That's what's in front of the x value. What's in the denominator? +1, right? So we're going to go up or down? Down and right. We always run to the right. Okay, so now we're going to go down 1, right 1, down 1, right 1, down 1, right 1. Okay, can you guys see where it crosses? If it crosses, The ordered pair is the solution, so we need to make sure we write that solution. So what is the solution for this one? 1, 2. Okay, so your ordered pair, your final answer on that one is 1, 2. All right. Are there any questions on anything we did in the warm-up? Anything at all? Okay. All right, so today we're going to add on to the next tab in our foldable. And in this tab, we're going to title it Solving by Substitution. Okay. All right, so go ahead and title that tab. All right, we're going to do 2 examples up here, and then we're also going to do 2 examples on right here. Okay. All right, so let's go ahead and take a look at example 1. Okay, now remember I told you guys I'm going to show you guys like a bunch of different methods of how to solve a system of equations. So you could take each of these equations and you could put them on a graph and you could graph them and get a solution, right? That's one method you already learned how to do. Okay? Substitution is a different method. Okay? So in substitution, we would use substitution primarily when one equation is solved for either x or y. Okay? So if we see one equation that's solved for either x or y, that's a good indicator that we could use the substitution method. Okay? So in this method, which equation do you see that's solved for either x or y? Equation 1 or equation 2? Equation 1. It's solved for y, right? So I know that y is equal to x minus 3. So what I'm going to do is I'm going to take x minus 3 and I'm going to plug it in the place of y in the second equation. Okay? Now, the reason why I want to plug it in the place of y is because then when I substitute its value into the place of y, I end up with an equation with only one variable. And then I can actually solve and figure out what that variable is equal to. Okay? So I'm going to rewrite equation 2, the second equation. And this says 2 times y. So in the place of y, I'm putting x minus 3. So it's 2 times that whole thing. 2 times x minus 3. Because this whole thing is equal to y. And 2 is multiplying by y, so I need to multiply 2 by the whole value of y, which is x minus 3. Okay? Then that equals 24. Okay? So now, in order to solve this, okay, I'm going to apply a distributive property and start simplifying my left side of my equation. Remember, this is a negative 2, okay? So negative 2 times x is negative 2x. What's negative 2 times negative 3? Positive 6. Okay? That equals 24. Now, I have an equation with only x's, so I'm going to try to solve for x here. What would you guys like to do first? Do you want me to combine the like terms, or do you want me to move the 6 over? Combine the like terms. Okay, so what's 8x minus 2x? 6x. Okay. All right, next, let's go ahead and subtract 6 from both sides. So I get 6x equals 18. And now I'll divide by 6. Okay, what do I get for my value of x? Okay, x equals 3. Now, what I have now is I've solved for x. X equals 3. And so I know part of my point, right? Because if I were to graph these, they would cross, right? If there's a solution, they're going to cross. And where they cross, I have an x value and a y value, right? I've found the x value. Now that I know the x value, I can take the x value and put it back in up here, and now I can find y. Okay? So if I plug x in, because it's 3, and I plug it in here, okay? So what is the value of y now? Y is 3 minus 3. Well, what is 3 minus 3? 0, right? So what is my ordered pair? My ordered pair is an x comma y value. So what is my x value? 3. What is my y value? 0. So I've just found the point that they cross on the graph without actually graphing. Does that make sense what I did there? Does that make sense why I put this 3 back in up here? Yeah? Because then once I have only numbers here, I can find the value of y. Okay? Are we all following that? So in the end, I basically took this 3 and I put it back in to where I started. And that gave me my second value. Okay? All right, so let's take a look at another example. Okay? All right, here's your second example. Okay. All right. So take a look at those two equations. Do I have at least one of them that's solved for x or y?
Yeah.
Yeah? Okay. So I have both of these actually solved for y, right? Okay. So I can either take this one and plug it into the y spot here, or I could take this one and plug it into the y spot up there. Doesn't really matter, okay? So I'll just take the top one, this one, and I'm going to put it in the space for y in the second equation, okay? So I'm going to rewrite this second equation with this thing in the spot for y, because it's equal to y, okay? So I'm going to get this whole thing, negative 5x minus 12 is going in this spot, and then I write the rest of the equation, equals 3x minus 4. Okay? So now, I have an equation here with variables on both sides. I'm trying to solve it for x to get that first value in my point, right? So what should I do? Do you guys want me to move the 5x to the right, or do you want me to move the 3x to the left? Move the 3x? Okay. That sounds like the consensus. Let's go ahead and subtract 3x. Okay, what's negative 5 and negative 3 make? Negative 8x. What kind of 4 was this? Yeah, make sure it's negative when you drop it down. Okay, what should I move next? 12. Let's subtract it because it's already positive.
Negative 12. You gotta add it.
Oh, did I miscopy?
Yeah.
Boo. Thank you. Okay, that's a negative 12, so I'm not going to subtract it. I'm going to add it. Thank you. Okay, so now what is negative 4 and positive 12?
8.
Positive 8, right?
Yeah.
Okay. And then last, what do I do?
Divide.
Divide by negative 8, right? Okay, what kind of 1 do I get for my answer? Negative 1. Okay. All right. So now that I have my x value, I can plug this x value back into where I started, right? So I can take this x value and I can plug it back into where I started, okay? And that will help me find the y value. So y is going to equal negative 5 times, what was the x value? Negative 1 minus 12. Okay, so what is negative 5 times negative 1? What do I get for that?
Negative 5. Positive 5.
Positive 5. Okay, and what's positive 5 minus 12? What kind of 7? Okay, so now I'm going to write my ordered pair. Remember the x goes first and the y goes last, so it's x, comma, y. Okay, so this is your answer. Okay, so we get that the ordered pair for each of those is the answer. That's the point where the two equations cross. Now, how many of you are like, Miss Miller, I really like graphing a lot better than this? Okay, on the test or the quiz, you're going to be able to do whatever method you like the best, okay? However, for the homework tonight, I do want you to practice this method, okay? Because it might seem hard at first, but maybe then once you practice it a little bit, you're like, oh, it's not really that bad, right? Okay, we're going to do another example. Okay, so, sorry, you can catch up later. Okay. Okay. All right, example number 3. Okay, you guys saw that sometimes on the graph the lines don't cross, right?
Yeah.
Okay, so I want to go over an example of what that might look like, okay, when we're solving by substitution, how you can tell, okay? So here's an example. Okay, in this example, do I have one of the equations solved for either x or y? Yeah, the top one. What does it solve for? X, okay? So if it's solved for x, I'm going to take this whole thing, and since this thing is equal to x, I'm going to plug it into the spot for x in the other equation. Okay? All right, so now I get 2 times this whole thing is going in the spot for x. So that thing is 2y plus 4. Now I'm going to finish writing the rest of the equation. So I had 2 times x minus 4y equals 8. Okay, what property should I apply here? Distributive. Okay, so I get 4y plus 8 minus 4y equals 8. Okay, what do you guys want me to do first? Do you want me to combine the like terms, or do you want me to move the 8 over? Move the 8? Okay, so I'm going to subtract 8 from both sides. Okay, and so I get 4y minus 4y equals 0. Okay, even though I get 0, I'm going to keep going. I'm going to keep simplifying. What's 4y minus 4y?
Y. No, 0.
0 y's. What's 0 times y? 0. So I get 0 equals 0.
No solution.
Okay, now, I heard someone shout out no solution. Okay, however, I want you guys to think about, is this a true statement?
No.
0 doesn't equal 0? Or it does? It does, right? This is a true statement, right? This statement is true. Okay? If all your variables disappear and you get a true statement, that means it is infinite solutions. Okay? Because this statement is true and all our variables have disappeared, that means there's not just one value of x and y that makes the equation true. That means there's many, many, many infinite values of x and y that are going to make this equation true. Both of these. Okay, Amelia?
What if it was like 3 equals 2?
So we're going to talk about that right now. Okay, good question. Okay, so I have one more example that I want to do with you guys, okay? All right, here's the last example I want to do with you guys. Okay, so here's the last one. Here's equation 1. And here's equation 2. Okay. All right. So, do you have one of those equations is solve for either x or y?
Yeah.
This one up here is solve for y, right? So we're going to take this thing that's equal to y and we're going to plug it in right there in the y spot, right? Okay, so here's what you get. Negative 2x minus 6 plus this whole thing. This whole thing is 2x plus 5 equals 0. Okay, now the reason why whenever I plug this in is that I put it in parentheses is because sometimes there's a number that I have to distribute. What would happen if this was a minus sign? Would I need to distribute that negative sign through? Yeah, so I always put it in parentheses, but in this case, because it's positive, when I distribute that positive, it's not actually changing the value. Does that make sense? Okay, so I get negative 2x minus 6. When I distribute this positive, it doesn't change the value. It just keeps these the same, right? Okay. And then now I'm going to simplify. So let's combine my like terms. Okay. What do I get when I combine negative 2x and positive 2x? Negative 2 and positive 2.
0.
0x, which is really just 0. So I get 0 for that, right? So I get 0 minus 6 plus 5 equals 0. Now, what does all these like terms combine to make? Negative 1. So I get negative 1 equals 0. Huh. Is that true? No, this statement here is a false statement, right? Okay, so if when I got a true statement, I got infinite solutions, when all my variables disappeared, here all my variables have disappeared, but I have a false statement. So what is that? What do you guys think that means?
No solution.
That's when there's no solution, when you get a false statement. Okay? All right.